Now, question 22 is a super tough question that's asking us about a rule that many people taking the SAT actually don't know. Here's the rule. Cofunctions of complementary angles create equal expressions. Now, if you really want to strive for a top score on the SAT and you're really trying to take it all the way, then you're going to want to have that phrase memorized. Cofunctions of complementary angles create equal expressions. Now, what it means in maybe an easier way than that is if you have two angles that add up to 90, then the sine of one of them always equals the cosine of the other one. And it's interchangeable. So I can say sine of A equals cosine of B, or cosine of A equals sine of B. So what does that mean for us here? Well, 24 and 66, those numbers do add up to 90. And so the sine of one of those angles equals the cosine of the other angle. So, according to that idea, I know these two things here, the sine of 24 and the cos of 66, they're equal to each other. Similarly, cos of 24 and sine of 66, those two things are equal to one another as well because it's the same idea. The numbers are switched, but 24 and 66 still adds to 90, and we still have the cosine of one of them and the sine of the other. So there's just some magic going on this question where people who have seen this rule before are maybe more likely to be confused because then it's like, well, can I do some shortcut because I know these pieces are equal? And the funny thing is, most of the shortcuts that come to mind, we actually can't do because I know that these two are equal to each other and I know that these two are equal to each other. So for instance, let's say the two orange ones are both equal to 1/2. Which they're not, but I'm just throwing that out as a sample number. And the two blue ones are equal to 3/4. So 1/2 plus 1/2 would be 1, and 3/4 plus 3/4 would be 1.5. So there's no real shortcut. They're both equal to each other within the groups, but they're not equal from one group to the other. So we have to basically be extra careful. Now, the way to think about this is if these two orange things are equal, I can rewrite that as sine 24 times sine 24. Or I could have rewritten it as cos 66 times cos 66. And that's because sine 24 and cos 66 by definition are equal to one another. They're cofunctions of complementary angles. So I can substitute one of them for the other one. Same thing for the blue ones. We can call both of these cos 24, or we can call them both sine of 66. So how does all this relate to the answers? Basically, what I'm saying for this question, kind of in summary, before we pick an answer, is that for the left side, we can have sine 24 all squared, or we can have cos 66 all squared. Because sine 24 and cos 66 are equal, both of those ways of saying it are kind of the same thing. Similarly here, we can say that this is cos 24 all squared or sine 66 all squared. So for the left side, we can pick one of those two possibilities, and for the right side, we can pick one of those two possibilities. And that's answer choice C. Answer choice C says we've got cos 66 squared, which is this. So we're kind of ignoring this one just because it's not in the answer choices. And on the right side, we've got cos 24 times cos 24, cos 24 squared, which is this one. So we're ignoring this because it's not in the answers. So we've got cos 66 times cos 66, we're squaring that, and cos 24 times cos 24, we're squaring that. So the answer to this incredibly interesting question is C.